Today we're going to look at how to draw some dot diagrams for things that do not obey the octet rule. Our steps start the same. We need to determine the total number of valence electrons. Nitrogen has 5, oxygen has 6. If we add those up, we have 11. Because that is an odd number, we know that we can't be obeying the octet rule. The next thing we need to do is draw a skeleton structure of the molecule. So we have N and O, and connect them with a single bond. So that uses up 2 electrons. We have 9 electrons left. Next we are going to distribute the remaining electrons as lone pairs around the terminal atoms. Well, they're both terminal atoms at this place. However, the more electronegative atom is the one that's going to get any extra electrons that are present. So we're going to put them on the oxygen first. 1, 2, 3, 4, 5, 6, and then we have 7, 8, 9 left for the nitrogen. Next we're going to place all of the remaining electrons on the central atom, which we don't have any remaining electrons and we don't have a center atom. And then rearrange the electrons to make multiple bonds with the central atom, or the other atom, in order to obtain octets wherever possible. So here, the nitrogen does not have enough electrons. The oxygen already has enough. So this pair of electrons is going to come in and form a double bond between the nitrogen and the oxygen, so it's no longer a lone pair. So the oxygen has 8. We now have 2, 4, 5, 6, 7 electrons on nitrogen, and that's the best that we can do. So our final dot diagram for NO is going to have a double bond between the nitrogen and the oxygen, 2 lone pairs on the oxygen, and a lone pair and a single electron on the nitrogen. Alright, next we have BF3. BF3 is an example of one that is going to have not enough electrons to make the octet. So first we count up the number of valence electrons. The boron has 3. Each fluorine has 7. There's 3 of them, so that's 21. So we have a total of 24 electrons. The skeleton diagram, we've got boron in the middle, the fluorines around it, and then single bonds to connect those. Each of those single bonds is 2 electrons, so we're down to 18 electrons left. And we put them on the outer the outer atoms first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Alright, now usually we would try to rearrange this so that everything has 8, and we could do that. However, in this case, boron only has 3 valence electrons. It only wants to form 3 bonds. So this is our final dot diagram for this molecule. The boron is one element that commonly does not obey the octet rule because it only has 3 valence electrons to start with. Alright, next we have XeF2. Xenon is a noble gas, so we know that noble gases don't usually form bonds. So something weird's going to happen here because xenon already had a full outer energy level. So same process, we count up the valence electrons, 8 in the xenon, 2 times 7 for the fluorine, so 14, and 14 plus 8 gives us 22 electrons. Skeletal structure, we have xenon in the middle and the fluorines on either side. Single bond to the xenon uses up 4. We have 18 electrons left. We start off putting them on the fluorines, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then all of the extra go on the center atom. So 12, 13, 14, 15, 16, 17, 18. So that uses up all the electrons. We can't rearrange to give everything an octet because the fluorine already has the 8 electrons and xenon has more than that. So in this case, the center atom, the xenon, has more than the 8 electrons that we usually get with the octet rule. All right, and XeF6. Again, if you see a noble gas in a compound, that should be a dead giveaway that something is going to be a little different here. So xenon, again, has 8 valence electrons. Fluorine has 7, but there are 6 of them. 7 times 6 gives us 42 electrons, so we have a total of 50 electrons to work with. Skeletal structure, xenon goes in the middle. 6 fluorines around it. Single bonds. Each one used 2, so 50 minus 12, we have 38 electrons left. We're going to put them around the terminal atoms first, so 1, 2, 3, 4, 5, 6 on each. There were 6 fluorines, so this will use a total of 36 electrons. We still have 2 left, and those extra electrons are going to go on the center atom. So in this case, xenon has 6 bonds and a lone pair on it. So while the octet rule is very useful, there are several exceptions to this, and you need to be aware that not everything will obey the octet rule. And you'll be doing several examples of this in your assignment. So the ones that are not going to obey the octet rule tend to be the ones in the middle. Once you've already filled up all of the exterior with with the total of 8 electrons, if there are any extra, then we put it on the center atom, and that ends up with, in this case, more than the 8 that we think it wants.